Hi, everybody. I'm Miss Shamblin, if you don't know me. But today we're going to be talking about conservation of matter. Now, this is a topic that we have covered a couple times in class already. For example, we covered it when we did balancing chemical equations. We talked about matter cannot be created or destroyed. It is just simply rearranged, right? So that meant that we had to get the same number of carbon atoms in the reactants as we do in the products, et cetera, et cetera. We had to put the coefficients in to make sure everything was good. Now, why does conservation of matter actually matter to us in the real world, and how are we going to be using it in this unit? So conservation of matter helps us to figure out if we have this much to start with, how much should we expect to end with, right? And so that's kind of what we're using it with this. So for example, if we are baking, okay, I'm a baker, so this is, what pops in my head. But if we're making cookies, technically all of the mass of our ingredients, the flour, the sugar, the butter, all of it should be the total mass of the dough that we have at the end when it's all mixed together. Okay. Now, no one generally weighs out the mass, but if we were trying to figure out, if each cookie needed to weigh 2 grams and we need to make X amount of cookies, then how much should our final dough weigh? And then we could proportion that out to our ingredients. So what we're doing today is kind of the math behind it. So for your notes, okay, make sure you get down the definition of the conservation of matter, right? That matter is not created or destroyed. It's just simply rearranged, which for the sake of us in this unit right now, that simply means the mass of the reactants equals the mass of the products. Okay, so make sure you get that down in your notes. Now, we're going to apply that out to the math of an equation, okay, which is just that mass of reactants equals mass of products. So if you start with 48.6 grams of magnesium and end with 80.6 grams of magnesium oxide, how much oxygen should we have expected to react that magnesium with? Now, you'll remember we've done this lab a couple of times where we take the magnesium strip and we light it on fire and it glows really, really bright. That's this reaction, right? It's really hard for us to test how much oxygen we applied to that magnesium. But the law of conservation of matter allows us to actually see how much oxygen is reacting with that magnesium by knowing how much magnesium we started with and how much magnesium oxide we ended with. Okay, which is actually pretty cool because oxygen being a gas, it's hard to weigh. Okay, so here's how this works. Okay, we're going to plug in the 48.6 in for our magnesium value like we did here. Okay, so we have that value plus our grams of oxygen, which for my algebra people, this is my X now, right? That's the variable we're going to solve for, equals the 80.6 grams of magnesium oxide, okay, which we plugged in right there. So notice how our chemical equation right here has now just become a mathematical problem. Okay, that's all this is going to be. And so obviously we're going to subtract 48.6 from both sides. Okay, to get our mass of oxygen. Okay, get out our handy dandy calculator. Minus 48.6 equals 32 grams. Okay, and that is our mass. Okay, so boom, done. Okay, that's how you do conservation of matter. Okay, so try your hand at the we do, and if you need to check into that video, go for it. Otherwise, continue on to the you do.